This video is a continuation of the last one. This is the second half of section 5.5 in our book, and we're still talking about our double angle identities. So I've listed them out here. And just as a reminder, cosine of 2a has 3 identities. Sine of 2a has 1, and tangent of 2a has 1. And I just want to point out that it's really important to know whether you're working with a or 2a. A and 2A have the possibility of being in 2 different quadrants, and you do need to understand which quadrant they're in. So I'm just going to do a really quick 2 examples of working with A and working with 2A and the difference here. So for instance, if they ask you to take this cosine of 16 pi and write it in terms of, or use a double angle identity to expand it, I would do something like cosine of 2 times 8 pi equals, this would be my A, because this is cosine of 2a, right? That would be my A. So I would use 8 pi as my A in one of my 3 cosine formulas. So let's just pick the first one, cosine squared of 8 pi minus sine squared of 8 pi. All right, so now if they said maybe the directions were write this as a single function, use your co-angle or double angle identities to write it as a single trigonometric value. So I know that cosine squared of 8 pi minus the sine squared of 8 pi, both of these are the same angle. And I have a nice double angle identity, cosine squared A minus sine squared A. So this must be A since it's the same. So I'm going to plug A into the other side. Whoops, cosine. Cosine of 2A, which is A is 8 pi. So I would get the cosine of 16 pi. Okay, so know whether the value that you have represents 2A or whether it represents just A. All right. So the other important thing is that these double angle identities, and in fact all of our identities that they give us, you can manipulate them. They don't have to stand the way they are. So for instance, if I didn't want this 2 here in front of here, I could divide both sides by a half, and now I have a new identity that looks like this. Okay, so yeah, you can change all of your identities as long as you're doing the same thing to both sides or you're doing an equivalent algebraic operation. Okay, so let's move on to our examples here. Whoops, let's undo that. First example here, it says use an identity to write each expression as a single trigonometric function, so one trigonometric function value, or as a single number. So meaning that if you can evaluate that single trigonometric function value, that you should evaluate it. All right, so this, I'm going to look at this and I'm going to have my little formulas handy, and I'm going to say, well, that looks a lot like my tangent formula, 2 tan A, 1 minus tan squared A. So this value here, since they are both the same, this is going to be my A value. So I know that this equals the tangent of 2A. So I know that the tangent of 15 degrees over 1 minus the tangent squared of 15 degrees equals the tangent of 2 times 15 degrees equals the tangent of 30 degrees. And what's the tangent of 30 degrees? Well, I never have these memorized. I have sine and cosine memorized, but not tangent. So if this is 30 degrees, and we said this was a half, and this is radical 3 over 2, it's opposite over adjacent. So it's going to be 1 over radical 3, and when we rationalize that, radical 3 over 3. Final answer. All right, so now how would you do something like this? Well, this looks a lot like, if I have my identities up, this looks a lot like 1 minus 2 sine squared A. All right, and I know that is cosine of 2a. So in this case, 1 minus 2 sine squared 22.5 degrees equals, this is going to be my a value. And I'm going to plug that into the other side of my formula, 22.5 degrees. And I know that 2 times 22.5 degrees is 45 degrees. And the cosine of 45 degrees is radical 2 over 2. Okay. So this is not quite what our formula looks like. We have a formula that says 2 cosine squared of a minus 1 equals cosine of 2a. But I want you to notice we're missing the 2 here, and this is not a 1, it's a 1/2. So this number here actually gives us a clue as to what they did to this equation. They divided both sides by 2 or multiplied both sides by 1/2 to get a brand new identity that looks like this. All right, so this is going to be our A. And we're going to use this identity right here to find our answer. So it's going to be 1/2 cosine of 2 times, we said pi over 8 is our A. So we get 1/2 cosine, what's 2 pi over 8? That's pi over 4. I know that's 45 degrees, so the cosine is radical 2 over 2. So my final answer is going to be radical 2 over 4. Okay, here's another example where we're not quite given the exact formula. I know that we have an identity that looks like 2 tangent of A over 1 minus tangent squared of A, but that equals tangent of 2A. But that's not exactly what we have here. We're missing the 2 on top, and we don't have a multiplier of 2 on the bottom. So how could we turn the 2 on the top into a 2 on the bottom? Well, we could multiply both sides by 1/4. Yes, because 2 tangent of A over 4 1 minus tangent squared of A. This is going to reduce to a 2. Gives me tangent of A over 2 1 minus tangent squared of A equals 1/4 tangent of 2A. Right? I had to multiply that to get this. So now I have a nice brand new identity. I manipulated my original identity to make a brand new identity. So I know that my A value is going to be 34. Okay, so that's A. So I'm going to plug that into the right side of this new identity. 2 times 34 degrees. So I get 1/4 tangent of 68 degrees. Final answer, because I don't know the tangent of 68 degrees. Okay, so let's move on. Let's do this next one. All right, so again, I don't have an identity that has a 1/8 in front, but I do have an identity, I believe, I think it's the sine, the double angle identity for sine. I have 2 sine A cosine A equals sine of 2A. So this is pretty close to this, except it has a 1/8 in front. Well, how can I turn this 2 here into a 1/8? Well, if I multiply by 1 over 16 both sides, that becomes an 1/8. the 2 and the 16 reduce to an eighth, so I get 1/8 sine of A cosine of A equals 1/16 sine of 2A. All right, so I have a brand new identity. So A, it looks like A is going to be 29.5 degrees. So when I plug A into my new formula, I get the sine of 2 times 29.5 degrees, which will finally end up being 1/16 sine of 59 degrees, which I don't know what that is, sine of 59 degrees. I guess I could plug it in the calculator, but they didn't ask me to. All right. So now how about this one? This is an interesting one. It says cosine squared 2x minus sine squared 2x. Well, the only formula that I have that looks remotely like this is cosine squared A minus sine squared A equals the cosine of 2A. Okay, so what's my A value? Well, I think that's fairly easy. This is not too difficult. My A value is going to be 2x. So I'm just going to plug it in my formula. I'm going to plug my A value into this side. Cosine of 2 times 2x equals the cosine of 4x. And I believe I am done. All right, so now we're going to move on to a different type of problem. We're going to write sine of 3x in terms of sine of x. All right, so for this problem, we have to write the sine of 3x in terms of the sine of x. So I think what I'm going to start off with is changing this into the addition of two angles. So I think what I'll do is I will change 3x into 2x plus x. And then I know the formula for the addition of two angles because 3x is not a double angle. All right, so since it's not a double angle, I'm not going to use a double angle formula. So I'm going to use the addition formula. So this is going to be the sine of 2x cosine of x plus the cosine of 2x sine of x. And again, I have to get everything in terms of just the sine of x. So when I pick formulas, I want formulas that only have sine. Well, the sine of 2x only has one formula. So that is 2 sine of x cosine of x times the cosine of x. But the cosine of 2x has three formulas. So I think I'm going to pick the 1 minus 2 sine squared x because it just has a sine of x in it. So now when I actually multiply these two terms out, I get 2 sine x cosine squared x. And I need to distribute this. So I'm going to get sine of x minus 2 sine cube of x. All right, so I'm close, but not there yet because I have cosine squared of x. So I'm going to change cosine squared of x into 1 minus sine squared of x. That's, if you can remember, an alternative equivalent form of one of my Pythagorean identities. And then I'm going to distribute this 2 sine of x across both of these terms. And my last step is just to combine like terms. And I'm going to end up with 3 sine x minus 4 sine cube x. And my answer really only has sine of x in it. All right, so the last 4 of your homework problems is going to be similar to this. So make sure that you pick appropriate formulas, and your instructions are to write us a trigonometric function of x. So your expressions just need to have something that looks like this in them.